Hey, this is a study video to help you to prepare for your Chapter 4 test. And as I'm looking at this, let's see, we're going to find the GCF of these terms in case you've forgotten how to do that. Remember what we do is we prime factor each of these. So 45, and you can go off and you can do a little, factor tree. 45 is 9 times 5, but if you put it in prime factors, that's 3 times 3 times 5. So let me just do the numbers first. 3 times 3 times 5. 18 is 9 times 2, so that would be 2 times, and then 9 is 3 times 3. 36 would be 4 times 9. 4 is 2 times 2, and 9 is 3 times 3. So I'm just taking care of the numbers first. Now I've got 5 A's. 1, 2, 3, 4, 5 A's. Here, 1 B and 1 C. Over here, that's A cubed in case you can't read it. So that's A, B, B, C, and then on the bottom one there's A to the 4, so that's 4 A's, and then 2 B's and 2 C's. Now the greatest common factor is the biggest number that divides into all of them. So I'm looking for what they all have in common. If you actually take out the C and greatest common factor, you have the greatest factor. That might help you remember that. What's the biggest factor in all of them? Because I think people have a hard time keeping that one and LCM separated. All right, so let's look. We're going to circle the things in red they have in common. Oh, there's 2 3's, there's 2 3's, there's 2 3's. The top one doesn't have a 2, so I can't count the 2 at all. The top one has a 5, but nobody else has a 5. So let's see. There's 5 A's in the top one, 3 A's in the second one, and 4 A's in the last one. So the most number of A's that all of them have in common are 3. Could have gotten more, but that middle one only had 3 to give me. Now on the B's, the top one's only got 1 of those, and all of them have at least 1, but we can only say there's 1 in common. And then on the C's, the top one also only has 1 C, even though there's more than 1 C in some of them. What they all have in common would just be 1 C. So let's go see what that all is. So they each have 2 3's, 3 A's, 1 B, and 1 C. So the greatest common factor would be 9, and then that would be A cubed B C. Okay? Different type. Let's try to factor a problem, one of those factoring by groupings, because it seems to be one that a lot of people have, forget how to do. Okay. Now, remember when I factor by grouping, I kind of split these things up into pairs. Take the first 2 together, take the second 2 together. And what I do is I look in each pair, what's just the GCF of each pair. So the first one, the biggest thing that would divide out of 2 and 10 is a 2, and then each of them have a C that you could take out. So what would you have left? You would have, if I had 2C squared and I took out 2C, there would be a C left out of the first term. And out of the second term, 10 divide out the 2 that you took out would be 5. We took that C out, but there's a D left over. All right, let's come to the second one. If I look at this, first of all, I notice that both of them are negative, so I could factor out the negative sign. And then there's a 3 that divides into both terms, so I can factor it out. They don't have any variables in common, so I can't take any variables out. So let's go back. If I had minus 3C and I divide out minus 3, I would have C left. If I have a minus 15 and I divide out a minus 3, I would have a plus 5 left. And then there's a D also left. Now, so you first found the GCF of the pairs, of each pair. But now what we're going to do, we took it down from 4 terms, and really what we've done is reduce the 4 terms into 2 terms when I wrote in blue. Now I'm going to write in green, and what we're going to do is we're going to look, okay, do these 2 terms have anything in common that you could factor out? Because this is now one big term, and this is one big term, but look, they have this C plus 5D in common. That's usually what happens with these problems. So I can take out the C plus 5D. Now what do I have left? Well, out of this factor, if I took C plus 5D out, I'd have a 2C left. And then this, on the second term over here, this one that I'm circling now, if I took the C plus 5D out, I'd have a minus 3. There you are, you're factored. Okay? Now, they might try to do something to throw you off, like couldn't they put, does it matter which factor I write first? No, I could put it this way, and that would be equally correct. So don't let the fact that they switch them up for you, because the commutative property says that when you're multiplying two things, you can switch the order that they come in. Okay, let's look at this word problem. The length of a rectangle is 7 meters greater than its width. Now, I don't know if y'all remember me telling you this before, but when you see like a greater than, that than there usually tells you the thing that would make a good variables coming next. So width, let me call, I'm going to need a way to represent in this problem, if you read it. I'm going to need a way to represent the width, the length, and then the diagonal. Because they talk about all these three things here, and so I'm kind of going, well, what am I going to do with all this information when I get it? And I'm guessing that since rectangles have right angles in them, that if we look, we're going to be talking about maybe a right triangle, and so we're probably going to use the Pythagorean theorem in this problem because it talks about its length, its width, and its diagonal. Doesn't tell me anything about the area, doesn't tell me anything about the perimeter, so that's the only equation I can think of that would involve those three things. So I'm going to go ahead and write that down. I'm probably going to use it. But getting back to the variables, if I let width be W, that can kind of help me here get going on my variables. The length of a rectangle is 7 centimeters greater than its width. So what's the length? I'm going to add 7 to something, and what I'm going to add 7 to, because remember, 7 centimeters greater than means I'm adding 7 to something. What am I adding it to? I'm adding it to its width. The advantage I have now is that I have these variables all have W's in them. I don't have one with a W and one with an L, you know. So now it says the diagonal is 2 centimeters greater than its length. So for the diagonal, you know, I could call it D for diagonal, but oh my goodness, I'd have so many variables running around. They say it's the length. It's 2 centimeters greater than the length. So I'm going to add 2 to the length. Well, the length was W plus 7. Okay? Well, that would make W plus 9, wouldn't it? So now, if you think about it, this is, again, a right triangle. And let me label the sides off that rectangle now. Well, its length we call W plus 7. Its width we call W. And its diagonal, which is the hypotenuse of a right triangle, is W plus 9. Okay, I'm going to clear the screen off just so I can have some room to write to finish this out. You can always pause the video. So but hopefully you've got that much on your paper, you should have it down. So the Pythagorean theorem says the 2 sides squared is equal to the diagonal, the hypotenuse squared, and we see that our diagonal here was a hypotenuse. So it would be W squared, and then we have W plus 9 squared. Wait, no, I'm sorry, W plus 7. The other side was 7. I looked down at what I scribbled to try to remember. And then the diagonal, which was our hypotenuse, was W plus 9 squared. There we go. Okay. So we're going to have to do a lot of algebra here to get this answer, because I want to know what the width is, and that's my variable. So when I find the width, when I find W, I'll have my answer here. So let me just kind of put it up here so I remember what I'm shooting for here. All right. Now this is W squared, but this W plus 7 squared is not W squared plus 49, no matter how bad you want it to be. That says there are 2 copies of W plus 7. And W plus 9 on the right-hand side is not W squared plus 81, no matter how bad you want it to be. It's 2 copies of W plus 9. So I can see that before I can even start moving anything around, I need to start simplifying some stuff. So I'll keep this W squared, and then let me do the distributing on this term right here. W times W is W squared. W plus 7 is 7W, but then you get another 7W when you go this 7 times this W. So that's 14W. And then 7 times 7 is 49. Well, I could clean up this left-hand side here because I've got W squared plus W squared. That's 2W squared plus 14W plus 49. W is kind of hard to read, but you heard me say it, so hopefully you'll be able to figure that out. All right, so now let me go do the right-hand side. I'm just going to do it in a different color just so we can keep it straight. W times W is W squared. W times 9 is 9W, but then I get another 9W right here. So altogether that's 18W, and then 9 times 9 is 81. See, it wasn't W squared plus 81, was it? Okay. So now I've got squares going on here. Anytime I've got a largest exponent of a square on it going on, what I've got is a quadratic equation, an equation with a square in it. And if you remember what our options are, they are either to factor or use the quadratic formula. But in either one of those cases, I need to get all the terms together on one side and have 0 on the other side in order to solve it. So what I'm going to do is I'm going to start moving the terms over to the right-hand side. I chose to move them because I wanted positive w squareds. I mean, I could do this all in one step if I wanted to. That would take the w squareds away, and 2w squared minus w squared would just be 1w squared. I could move the 18w to the other side by subtracting it. Remember, we always do the opposite. And over on this other side, they'd cancel out on the right, but on the left-hand side, 14w minus 8w would be negative 4w or minus 4w. And then I need to move the 81 over, so I'd subtract it. And now I've got 0 plus 0 plus 0 is 0 on the right-hand side. But when I subtract the 81 over here, 49 minus 81, that's going to be, remember, you can think of it as 81 minus 49, but the result's going to be negative since the bigger number was negative. So let's see, 11 minus 9 is 2. We'd have taken 7 minus 4. It would be 32. And again, you could use your calculator, right, if you're having trouble with that part. So now we're going to factor it to find the possible width. So we know it's going to be WW, and we're thinking, what do I multiply to get negative 32? And at the same time, I want to add it up to that number in the middle, negative 4. Okay, so we've got two negatives going on here. Okay, let's see. I know that 8 times 4 is 32. If I need to get these 8 and 4 to add up to negative 4, I'd need to make the 8 negative. So negative 8 plus 4 is negative 4, and negative 8 times 4 is negative 32. So I always kind of got to mess with the signs a little bit. So we have a minus 8 and a plus 4. So now in order to solve, what I do is when I'm multiplying two things and they equal 0, it means one of the two things had to be 0 in order to even get a 0. So we say, well, maybe it was the first thing, the w minus 8, that was 0. If I add 8 to each side, I'd get w is 8. Let's go check out the other one, because, am I going to have two answers here? Let's say w plus 4 is equal to 0. Well, if I subtract 4 from each side, I get w is negative 4. Is it possible to have a width of a rectangle be a negative number? No. So we throw this answer out, and our width is actually just this other one that we got over here that was positive. It is 8.